Any platform can help you save
Hello.
money. But when it comes to investing, you need a guarantee that your goals are within your reach. You need
I'm gonna share a
advisors.
screen.
Goal-based plans that make achieving your goals feel more affordable. So, create a bespoke plan for your wedding, business, education, new home, travel, or retirement with Rise Vest goal-based plans. Download my Create an investment plan to enjoy great returns. Rise. Investments that help you grow.
8 a.m. It's Paul. I was listening to the album. Good fucking luck. You're on your own. We got a problem. Check this out.
Okay, so I don't know who's online or who is not online, but uh, today I intend to teach you guys about this new programming language. It was it is being managed and maintained by me. I'm the appropriate of it. Um, to introduce myself, um, I'm Cosma. Yeah, just call me Cosma. The GitHub, my GitHub account is I can share the link to the project that I want to talk about today. So it's a new project. Okay, it's relatively new. Some of you must have heard about it. Some of you might not have heard about it. But regardless, I would like to talk about it because I, as someone who's maintaining it, who has built it, I feel excited to talk about it. As a self-learned person in IT, I feel like I should talk about it. So, if you don't mind, follow up with me. I'm going to be taking you bit by bit. Okay, so I decided to make it I decided to make this live because uh because okay, I'm not a very good person at cameras, but I feel like I should share out with the world. Been posting it on peer list, but I think more people use YouTube for learning programming, especially those who want to be systems programmers and all that stuff. Than they use peer list and other sites. So that's why I chose. That's why I chose this side. Now, the new programming language I want to talk about is called lwanga programming language. Uh, if Let me share the GitHub link. Let's look at its GitHub account. Maybe I've shared the link. You can check it out. But to summarize it, it's a low level language. Literally, if you have ever used the Rust before, I think you know what, you'd find this one a little bit more adoptable than I don't know. I've never used Zig, but maybe even than Zig. So it's called Ranga programming language, and it is focused on low-level systems and cybersecurity, like crafting malware, payloads, and all that stuff. It is a compiled system programming language designed for system research, for security researches, penetration testing, shell development, among others. And it's built on LLVM. It's provide direct access, minimal runtime overhead, and powerful features that are for creating security tools and making exploits. So, why would someone want to adopt this new language? That's the question you can ask yourself. Why would someone want to adopt this new language? Okay, I lead the team that is developing it, but I won't say that I know it. I'm also learning it like you, but I'm finding it quite enjoyable since it's very easy to get started with. But rather than now we have only a Debian build, We don't have other versions, but you'll find it very easy to adopt because it's just free commands and you are ahead of the game. You don't have to install multiple runtimes and all that stuff because it doesn't require runtime. It just requires a compiler and it runs directly on your hardware. That's the bit of it, more like assembly. So, and it's not hardware. Okay, let me just give you a brief overview. Why learn Ranga? The name is Ranga. It's a Uganda name. Has a very very huge history. Ask me why I chose it. So why Ranga? Why not trust? Why not C? Um, Security first. That's the first point. Well, if it has inbuilt encrypted screens and it has post-independent code and makes direct system calls using the syscalls function. And then the second point is that it has minimal footprint. Has minimal footprint. So the hell world of Ranga is under 10 KB. Can you imagine 10 KB? So you can look compare with other languages and you can see that this is really something different. Um, another topic point we can talk about. Another point we can talk about. Maybe let me review while going through the docs. Then first one the time I show the time it's time for coding, but let me first show you the docs of this project. Maybe you can see what I'm referring to, and maybe you can reference it in case you want to. Okay, no one has joined yet. That's okay. I just feel like I should talk about this, and it's the project I'm focusing on at the moment, and I really want to make it great. So, any feedback, whether positive or negative, I'd greatly appreciate it. Thank you once again. Okay, now why, why, why Ranga? That's the question you are asking, or I was asking. So it is I've said it's a system first, and it is encrypt. It has encrypted strings, has post independent code, is not tied to one location. It's dynamic and it makes the ellipsis calls. If you've ever done low-level programming, I think you know that very well. Then it has minimal footprint. The whole world program is under 10 KB. It has no libc dependencies, so you won't find the weird printf functions here. Then we have another issue. Another point why you would choose Ranga is low-level control. Inline assembly, naked functions, and register access. My hardware people are not hard. You'd like that. That's why most people prefer C or C++, C and Rust for system calls, and some even go raw with assembly. But we can drag that on and on. But if you can do inline assembly within a low level language, why would you have to learn different language? Or do you learn assembly when and maybe C and C++ when you can do all that from this one single language? So if you maybe if you've been using one language and you're very comfortable with, maybe you've been using assembly or C, uh, you won't like shifting. But if this is the new language, you are just a beginner and want to get started with learning programming, I think, I mean, low-level programming, I think this is a good way to get started. Trust me, it is. If it was a choice I could make, I would have learned this than learning C, but since no one had that idea yet, here we are. But I'm not downgrading C. Don't get it twisted. I'm just saying that at least give it a try. Got the repo, go through the code and the documentations. Leave a star if possible, leave an issue if possible, leave a review if possible. Anything you do, or you can just send us a mail and say, "Hi, Cosma, I like this project too. I don't like this project because it's on A, B, and C." And I'll be like, "Okay, cool. Let's see how to improve so that we can get you on board with that." Another issue and another reason why you should use Ranga is it has modern tooling. We use the LLVM backend, then they have code formatters and syntax highlighters. All of them are inbuilt, though not yet supporting the, or not yet officially released, but the packages are inside the repo in case you want to use your favorite text editor like Visual Studio Code, your Sublime. All have those and even prettier extension. So you can add them manually if you know how to do it. But since we are still in testing phase, trying and error handling phase, I prefer if you use a terminal, maybe Vim or Nano. Personally, I prefer Nano since I use a Debian system. Then we have we have another issue. Is that another point is that it is cross-platform. Um, Now here's the thing. This point that means that you can run it on any machine, whether it is it is using a it's 8664 chip, or it's using ARM chip, whether it's Linux or macOS or Windows, you can run it. It's cross-platform and it is not tied to the compiler design like assembly, but has the same power as assembly. Then again, right now we have on rebuild for Linux. So if you're using Windows, at least put on a WSL, please. And if you're using macOS, we're going to, we are really sorry for that, but you can use a VM and you have a, or you can have a the next terminal because it's totally Linux at the moment. I haven't got opportunity to build for Mac OS or Windows because I'm constrained by time and resources to test from because I don't have a Mac, so I don't have a way of testing on Linux. I mean on Mac OS, but when we progress, orders are going to come. Once I confirm that we have a stable release, I will be able to build for all the platforms so that our guys can test it and can try it and give the point. But now only Debian systems can run. Okay, now we look at the features. We have the Alexis cores. Yeah, I'm taking soda water. I'm taking soda water. That's my nerves when I'm working, when I'm coding. So we have the coding features. The core features these are the ones we have directed scores, and these ones may the like we call there are this the our compiler make direct system calls without any libc overhead. You are not importing any library, you are make direct system call to communicate directly with your hardware. Then the second feature is inline assembly. Now imagine you can you can have the power of assembly and the elegance of a modern language which is human friendly. So it has the Intel and the AT&T syntax support. That's literally what we mean by having inline assembly. um Another issue is we can use naked functions. These are functions without prolog epilogue for shell code. Remember we said that is most targeting system analysts, expert developers, and security researchers. So shell coding is one of the most important things that we have to address when we are talking to them. And these naked functions, that's where they shine. We have encrypted strings. So at compile time string encryption with the enc keyword. In case you want to encrypt it, you have to use that keyword. How it works? Let's say someone is using a reverse engineering tool, like maybe should know any that you've chosen. When they try to reverse engineer, they will be only saying gibberish. They won't be saying anything useful. So your payloads or whatever you're coding it will be safely delivered, minimal footprint, and hardly decryptable. Then another feature I have is a post-independence code. Now here we have built-in post-independent code generation for the shell code. So it is hard to for the antiviruses on the machines to detect it. This is a disclaimer. I'm not telling you to go break the machines of other people. If you're using this language, please use it well, safely. What can I say? Well, safely. I don't know what is the right way to word it. Then uh, another point we have is Uh, we have we have unsafe blocks. We have unsafe blocks. So what are unsafe blocks? In the case, remember we said we are that it has. If you look at the first feature that we talk about, we talk about having direct system calls. Those direct system calls come at a cost that we the language is non providing in security. It is providing elegant security, but you have to know what you are doing. So we give you access to the hardware to anything that you want to do, but you have to be sure that you know what you are doing, and we shouldn't contaminate your code. So to achieve that, um, we allow you as a user to we allow you as a user to to make direct system calls. Yeah, you make sure to make direct system calls, but within the unsafe block. I'm sorry if your system stammering. Um, like I said, I think this is my first video on YouTube, so this is not something I do regular, but I think I should make it regular. At least every single day I should be making one live to explain a thing or two. Yeah, but as you are bearing with me, let us proceed here. So those are NSF blocks are for explicitly low level operations. Whenever you want to do a system call, just open them up and then you'll be able to make that call directly from within there. Um, what else do we have to talk about? We have zero runtime. Like I said, no standard library, no, and we have very minimal dependencies. So there's no standard runtime for it. We don't have the virtual machines. We don't have anything like that. We abstract all that over. So just have to install the compiler, and the language build have to once you have the compiler, it just runs as fast as possible. That's what I'm trying to say. Yeah. So so now after looking at the features, now you know this is then something that is going to be trivial. This is something that is going to be for maybe monking, or I don't know. It is something which is going to be thoughtful for cybersecurity personnels. I don't really think that it's going to okay. A time is going to come when it's because of course we have some libraries make a little bit general because we know we need that elegance even in high level applications like backend and all that stuff. Yeah, we have them. That's a plan I have because I love building. But I now think you should look at it from this perspective only. Now we have the type system. The type system has like we use unsigned integers mostly for the types. For example, we have unsigned 8, 16-bit, we have 8-bit, 16-bit, 32-bit, and 64-bit strictly those unsigned integers. Then you have raw pointers. We can denote them with PTR. Then we have registers. Register type for they are used for inline assembly. Then we have structs. If you know C and then the low level language, you know structs. Composite structs literally, and we have packed structs. These are memory layout and control structs. Then we have tooling. Now tooling, the tools that comes with the compiler, I have the Ranga C. Ranga C is the LLVM based compiler with the optimization levels. Ranga formatter is the code formatter, and then the cat is the syntax highlighter. Then they have the VS extension and the VM plugin. Like I told you, all of them are going to be coming with the package when we're making the stable release. At the moment, you have to bear with the highest levels of abstraction, if I dare say. Now, where was I? Okay, so the instruction guides are here. If you want to follow along and you have a Linux machine, please follow that instructions. I mean those instructions. They're just 3 simple steps. You put the project, the Debian package of the project, then you install it and then you fix the dependencies, and from there you are free to run. Uh, as you can see the hello world program, it looks very simple. Just go function main, and then you assign it to a 64, you make it return a 64 unsigned bit integer, then you let them, you put in the message it, you pattern it to a pointer, then they put in the message board, and then you declare an unsafe function, unsafe block, and then you make a system call and everything comes out. After making the, you return the 0 to show the success, and then you compile the project. After compiling, you call it, it will print out beautifully expressed thingy. So again, on the repo, since it has no website yet, took the liberty to draft the documentations that can be used at the moment by the people want to use. So you can follow the documentation. You have the core documentation. It contains the tutorial series, which are 40 lessons of comprehensive learning path of language references, drive installation guide, system code reference, and style guide, and cheat sheet. IDE integration, tools documentation, packaging, etc, etc, etc. So uh, a lot of things have been talked about. Right now, a few days ago, 2 days ago, I released the third version of the third unstable version. Literally, sorry about that. Um, Full compiler with the open backend. On the backend, it had code formatter highlighter. We fixed some issues that we had with bitwise operations. They are kind of hatchy. I want to show that they are fixed, and we are using the IMIT certificate and license. You are free to share, to research the project or use it in anything you want to do to cite it, but please let us point the credits to us or to me. I really need them. Like, okay, thank you. It is done. It's okay. I hope you understand, though I'll feel a little bit discouraged. Okay, so now that you know, I think you should jump right away in the documentations. I'm sorry for making that it's taking long. Like I'm kind of slow, but like I told you, it's a new thing, so we need to give it to go slow so that we can touch everything explicitly without leaving anything out. Since we are going to since we are going to do a lot of things, and we need people to understand what they are doing. That's why we have 40 descriptive lessons. And once you want, if you want to follow along, like I said, you can install your compiler. When you install your compiler, you are free to learn. You are free to follow along with what I'm doing, and then you can chip in case you want to chip in. You can drop comments in there. You can give it a thumbs up, or you can even follow the channel, because I'm going to be posting the 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 tutorials. I'm going to be posting tutorials. I'm going to make it. We'll be doing lives, and then after doing the live, it's going to of course be released here. Just please check it out for it. You can always leave a review. I really love feedback because that shows that what I'm doing is important. Okay, some people find it relevant, and that feedback helps me to make it a better product. Right now, I'm a solo developer, though I talk as a team. I welcome contributions and support again. So the lesson number one, is going to be at the introduction, and so I think I should. We're going to learn from scratch how to program in lwanga programming language, and well, let's get started without any further ado. So now, I presume you already have set up your environment and you are ready to start. Once you have, then I should get started immediately. Okay, so these are the first lesson is the introduction. Now, um, this is the what is Ranga? Again, that's a question I ask ourselves. Ranga is a low-level programming language. It is a compiled systems language, and it is designed specifically for security research and penetration testing, shell development, exploit creation, and systems programming with minimal footprint. Have to emphasize on that one. General purpose languages. Unlike general-purpose languages, Ranga is built from ground up for security professionals, pen testers, and systems programmers. So, because we need direct hardware access and minimum binary sizes. So, if you are a high-level developer, develop web apps, I really don't think at the moment this is what you really need. This is for people who like tinkering and safely. So, why was it created? This is a question everyone has been asking me. Okay, all my friends have been asking me the same question. Why did you create that? All the firms I've posted in have been getting the same question. The senior engineers I sent it to have a check at it. Most of them asking me the same question. Why would we have to learn a new language? So I decided to include the reason in the documentation. The problem. The problem I was solving. This is the study case I was handling. Situated such as a system of programmers often face these challenges. As you can see, we have C is as though you hear everywhere. Everyone says it. C is unsafe. C is unsafe. C is unsafe. It is too unsafe. So what do we do about it since it's favored almost everywhere in low level development? So one of the challenges C is unsafe. It is easy to make mistakes, so and it has no modern features that help us to make programming enjoyable or make it safer. Then the second problem we're addressing is Rust is too complex. If you have tried to learn it, I'm sure you can agree with me on this. Rust isn't for the light-headed ones. And easy to be able to articulate it really well to understand it. But I'm not saying it's impossible to learn it. Of course, it is possible to learn it, but just heavy. Another point is Python is too slow. Yep, Python is too slow for system operations since it is interpreted and it cannot create standalone binaries easily. There's a lot of juggling that is involved in it. And then assembly is too low level and hard to maintain, and it is platform specific. So if you look at all the favored languages for those operations, the languages that are favored by system researchers, pen testers, and the tools builders, all of them have some issues that they have that we have come to address from one single point. And though, if you're going to ask me why I did it, that is the reason why I did it. So, why was Ranga created? Those are the reasons. Now, the solution. Ranga bridges the gap by providing the following: low-level control like C and assembly. We have modern features like adding the XPST unblock unsafe block inside the code. That's a good feature that shows that whatever you are expressly saying, you as a programmer, that okay, I know what I'm going to do is not safe, so I'm putting it here so that it doesn't cause any complications externally. We have minimum binaries, so it leaves that solves the Rust problem of large binaries. And then we have a simple syntax that is easier than Rust and safer than C. Okay, in syntax I find C very easy. So it is on par with C in the syntax, or could be a little bit more elaborate, but more safer again. Then we have direct system calls. You have no libc dependence, like I've been saying since the start of the video. And then you have inbuilt security features like encrypted strings. You have host function, etc. So After solving the problems, that's where we come up with this. Now, the language philosophy: explicit over implicit. Now, in Ranga, everything is explicit. Yes, yes, I'm not lying. Everything is explicit. You must explicitly mark unsafe blocks and unsafe operations. For example, you are making a system call, have one message and the length. Now they have made an unsafe operation, a system call, and why do we require secure why would we are we making it explicit is because system calls require precision. Implicit behavior can hide bugs and vulnerabilities that can make the code not like can lead to issues in production. Yet we are solving the safety and ensuring safety and effectiveness of the program should do. We need every line of the code to be doing something that's little and should be doing a very good job at whatever it's doing. Now, the second philosophy we are going to look at is um, minimum runtime. Ranga programs have zero runtime overhead. Why? No garbage collectors, no sun library by default, no hidden allocations, no system calls with the libc. Why? Smaller binaries are harder to detect, faster to execute, and easier to analyze. Precise, concise, and on point. Then, um, another point we have to talk about is safety where it matters. Ranga provides safety features, but doesn't force them anywhere. Yeah. So, when I introduced it in a cybersecurity Kampala group, some good friend of mine was flabbergasted of it. I was like, okay, he engaged me on it directly from the group. It's called Cybersecurity Kampala. If you've ever been in part of it, I'm sure you could have found that message there. But it is an open source group where you can put whatever you want, like anything you've been doing about low level programming. I mean as long as that something is about cybersecurity, you can put it there, whatever you are developing, and people can look at it. So the guy was like, okay, I first did the project introducing the version 1.02 release, and it was a public text that was releasing, introducing the programming language. So I was like, this looks like Rust and assembly. Uh, are you using natives only or need packages externally for development? And another question he said was like, is it okay for it to embed unsafe into safe? That will be good for experts. That's what not first, even if I pointed it out. And then I was like, I don't want to warn debuggers for checks. And that's why it is okay to embed unsafe into safe. And to him, I replied like this: it is mostly native plus LLVM backend because that's one we rely on for the compiler design. And then I was like, though there is no libc, no external runtime packages, packaging exists for distros, Debian per now. But dev-wise, you are working directly with the compiler and the LLVM. That's what I told him. And they were then on the question of is it okay for it to embed safe and unsafe? I mean safe into unsafe. I was like, yeah, you can drop unsafe blocks into the otherwise structured code and it's intentional for exploit development. It is intentional for exploit development, shellcode crafting, etc. And he was like, okay, he was really interested in it. So it has minimal footprint and encrypted strings as well as position pending code and naked functions help keep the shellcode stealthy. So there were that so that it will make it good for exploit development and avoid detection. Then he was like, hey, it is opinionated then and strict. or is it like I was like, now is it opinionated and strict, or uh, you'll be like, hey, here's Mayar, good luck, chaos mode. I was like, and then he commented on the structure that it is clean and structured by default, unsafe when you need raw control, no libc, minimum footprint, encrypted strings, peak and negative functions, then come on surface, but full metal underneath. And it was like, I had to check it out. So yeah, it's not chaos mode, it is structured by default, so you can get clean surface to work with, but not over restrict. Yes, we are safe and unsafe at the same time. It is not over restrict. um you can drop unsafe blocks and inline assembly wherever you need the raw control. I think of it as opinionated enough to keep things tidy. No libc, no encrypt. We have encrypted screens, we have position independent coding compilation, then we have naked functions, we have flexibility, and it is enough that you can you can feel free to go full metal when situation calls for it. So that is the kind of a weapon we are dealing with at the moment. Some more questions. I'm getting a lot of questions recently about it, and I feel like I should be addressing them along there whenever I'm talking about something about it. Anyway, so today I need us to cover something very good, to cover the basics, so that you can switch from there tomorrow. Every day, I'm going to be giving you one video, maybe an hour or two, and we talk about it. We go through the examples and the language one by one, so that you can easily catch up with it. Otherwise, let me continue with it. So the third point we were talking about was Ranga provides safety features but doesn't force them anywhere. And that's why I read the other guy's messages to you guys. Ranga provides safety features but don't force them anywhere. For example, as you can see in that example, you have it is safe by default. As you can see, you define explicitly the variable types, but you can go unsafe when needed. For example, when you need to make a system call. So why did we do that? Because system programming requires unsafe operations, but they should be clearly marked. You see, we are not taking away the unsafe tools, see, but we are making the person make the unsafe operation when they are aware. In C, you can make a system call and not even know that you are making a system call, especially for novices and beginners and those who are not experienced. But here in our programming language, in Ranga programming language, when you make a system call, without, or like we make an unsafe call, you get an error that, okay, what you're doing is unsafe. Please wrap it in an unsafe block. And again, he give you the location where that unsafe operation is, so that you can review and be sure that, okay, I was intending to do this. If we are intending to do that, then you have to just declare it in the unsafe block, so that we count you accountable for whatever it's going to do technically. Then you have the fourth design. I mean, the fourth design decision, it is security first. Our built-in features like um, compile time, string encryption, you have position independent code generation, you have code abstraction, and you have naked functions. Yeah. Why security tools have unique requirements that general purposes don't have? That's the reason. So you see everything we've talked about so far. They are pointing in they are emphasizing stealth operations and effective payload generation and shell code. So now the part most people are interested in comparisons. You guys have comparisons, I know. Um, we're going to first compare with C. So how does it compare with C? You look at that table, we have a future, then C, and then Ranga. If you if you look at the first feature is memory safety. C is not memory safety. I don't know when I'm making unsafe operations, but here you have to explicitly use the unsafe blocks. There is no implicit operation. You have to know that whatever you are doing it out of the right mindset. Then the second comparison, C has a small binary size. I concur with that, but we have smaller one. No external libraries. I'm going to emphasize that no external libraries. We need everything in house. You need to know what you are doing. Good. Then you have a running curve. It is moderate and easy. Then we have types. The C is moderate, but ours is easy. Ranga is easy. Then type safety. C is weak in type safety, but Ranga is very strong, like Rust. Doesn't fuck up. I'm sorry for using for language. Please forgive me. Then then we have modern features, and C doesn't have modern features. For example, I can give an example of encrypted strings, etc. etc. Then we can compare with the Rust. Uh, Rusty in memory safety. In memory safety, we Rust uses borrow checker, but for us to have the explicit safe block that you use for memory safety. So as you can see, ours is a little bit more easier to implement and to control. Then you have a minimal binary size compared to Rust. Then Rust has a steeper learning curve. I tried running it once before I created this language. Honestly, I tried not once, not twice, or around 5 times, but I failed to click it. And I'm not as I saw. Okay, I'm not strong-headed, but I'm not so light-headed. I know how to hold my goal. So Rust isn't really something that a total novice can just come and crash. To be honest, you need to have a good reason. That reason gives you the zeal. That reason gives you that drive, that fuel that you need to keep pushing it up until you can master it. And I think maybe I liked it. I don't know. You can tell me if you find it easier. Then another thing you can talk about is memory. I mean, it is the learning curve. I mean the syntax complexity. Rust syntax, you can agree with me, is high. The complexity is high. That's why the learning curve is steep. Then, but for Ranga, it is relatively smooth. It is not so complex. It is gentle because the syntax is smooth. Then another one we can look at is saturated features. General purpose. Rest is general purpose. Then Ranga is encrypt. It is specialized. It isn't a general purpose language. Like how you see ARA. ARA is specifically for statistics. If you're doing statistics, I don't know why you'll be learning ARA. Where are you going to use it? I don't know. You don't know. So like how you see how ARA is in a statistics. Now that's what we are making Ranga in a cybersecurity world and low level engineering. Then we have Ranga versus Python. Uh, the first feature we are going to look at and compare is execution. Python is interpreted and then Ranga is compiled. Then the binary size, it depends and it needs a runtime. For Ranga, it is minimal and it comes directly, no runtime needed. Then performance, Python is slow. Ranga, since it is native code, it is faster. Low level access, you can see Python needs some C wrappers and C++ wrappers to do low level operations, so it is limited. If you look at Java, you need GNI, but for Ranga, it is full low level access, and then deployment. For Python, you need Python installed on the system. Then for Ranga, you need it as long as you have the standalone binary, whether the computer has C, whether the computer has C++, whatever it is going to be it is going to it you can just deploy. So as you can see, it is friendly for each and every one, if you ask me. Okay, so for 45 minutes I will have since I started this live. Unfortunately, haven't got anyone in house, but it's okay. Just did it. No, 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 I haven't got anyone yet. Someone's going to come and laugh at me. They're like, "Oh, what the fuck were you doing?" I was like, "Okay, I'm just working on this, and I just want to introduce the language that I love the most." So, now as you can see, we are we are really getting it out, and we are giving a reason for everything that we are doing. There's nothing that we're doing for granted. There's nothing that we're just doing. We whatever the decision we're taking here is informed. Whatever reason we're taking here is informed. I made research personally. I reviewed the documentations. I looked at the design decisions. I looked at everything, and that's why I came up with this. And so I love hardware. I love tinkering with systems. So that's why I came up with this. Now, what can you build with Ranga? That's another question. What can you build with Ranga? Point number one, security tools. For example, you can see in that example there's a port scanner where you can scan. You can write just that simple script can help you scan the ports. So as you can see, function scan port. You provide the IP address and then the port number. Then you return the 64-bit unsigned integer. Then you can inside there you can create a socket and attempt a connection. Then return one if open, zero if closed. Simple as that. Then you can write shell code, position independent shell code to be precise. And you call it as naked function. If you need the shell code, you call it a naked function. So you use the keyword naked. Fn is always the function. You're going to be seeing it a lot. That's the keyword for function, since this is a functional program language. You Okay, sorry about I was cut off. Yeah, I was cut off. And just let's just wrap up this for the first time so that we can do something else. Today's 1 hour is about to end. I want to stop at halfway four. So let's continue with the introduction to Ranga. Okay. Okay. So I was I was talking about the projects that you can do with this language. Yeah, we were talking about what we can do. So as you can see, we are able to make direct system calls. We can build shell. The first point I showed you was ability to develop security tools, and the example is a port scanner. Then another one, I told you we are able to to write shell codes. You can see this shell code. This is a naked function. The name is obvious, and then you can see inline assembly within it. So if you know assembly, and then even the execution code is it is also there, so it can auto run itself. Then we have system utilities. We can build system utilities. For example, file encryption tool. We can build drivers and all that, and control hardware at a fundamental level. Then um, another another thing we can do with it is we can write networker tools. For example, you can develop a simple TCP server with it, and you'll be none the wiser, if you ask me. Uh, as you can see, there is a simple script there as well for it. So let's look at the key features faster. We have Ranga programming language has direct system calls, no library dependencies. You talk directly to the kernel and you use that unsafe block. So using the unsafe block, uh, you can communicate with your computer's kernel direct, and you can you do any system operations that you wanted to do for a long time, but you were being hindered, though you didn't know safely what you are doing, so that you can do it safely. And uh, uh, you can communicate with your computer's kernel direct, and you do any. Then another thing that we can look at. Sorry if my network is bad, guys. You please bear with me. We have inline assembly. So how is this done? Like I've showed you in the shell code, you can mix high level and low level code seamless. You can write your high level Ranga code, and you can mix in assembly without any issue. So another key feature we can look at is encrypted script strings. Strings are encrypted at compile time. For example, if you say you have a string called password, like I told, strings are taking I looked at it as the pointers. You use the enc keyword, and then you define the string. The string never get appears in plain text. It is encrypted, so that even when they reverse engineer, they cannot know what it was. Then type safety. It is a strong type system, it has a strong type system, so it prevents common bugs. For example, variable definition mismatch, variable data type mismatches. All those are done away. You have to know what you are doing again. That's why I'm putting emphasis. Then we look at zero cost abstractions. High level features compile to efficient machine code. So you write something high level, but it is compiled down to machine code and it's executed immediately. So for example, we have that struct which is called point. It has two variables, x which is a 64-bit unsigned integer and y again is 64-bit unsigned integers. Then we can let variable p which points to variable p which calls the struct point, and then we feed it the arguments, and then when you compile, it compares directly to memory access, no overhead. So why should we use Ranga, or who should use Ranga? Ranga is perfect for penetration testers, creating custom tools, security researchers, developing express malware analysts, understanding low-level code, system programmers needing minimal binaries, system programmers This is for you really. If you need very minimal binaries, CTA for capture the fragger players solving binary exploitation challenges and embedded developers working with constrained resources. Then, key in point, it is not ideal for the following. Please look here or take this seriously. It is not suitable for web development. So for that, you can use Go, you can use Rust, you can use Node.js, Django, anything you want to use. It is not suitable for GUI applications. You can safely use Rust, or C++, or Python. It is not safe for data sciences. Use Python or R. And it is not suitable for gen application development. For that, use Rust, Go, or C++. It is a low-level language. Please, let's not force things at the moment. Then the design decisions. Why no standard library? Isn't that insane? Ranga has no default standard library. The reason it keeps binaries minimal, forces explicit dependencies, prevents broad, gives you full control. You write more code, but you know exactly what is in your binary. Yes. Um, Well, I can give you a case study. When I was learning C, I asked myself, we always import stdio.h, but what exactly is in stdio.h? How does it work? All those questions ask yourself now. Here, we don't import those ones. You only work with your code. Whatever is in your file is something that you've written. No standard libraries, no what. So the impact is you are going to write more code, yes, but you know exactly what is in your code. Then another thing is why explicitly unsafe blocks. The decision. Unsafe blocks must be in unsafe, like unsafe operations must be in unsafe blocks. Reason are the following. It makes dangerous code visible. It's easier to audit security critical code. Helps prevent accidents and declares separation of code safe and safe. So the impact, it is slightly more verbose but much safer. Like I told you, in C you can write unsafe operations without even knowing. And when you compare and you get your code running, but you won't know that you're doing something catastrophic. But here we tell you when you're trying to compare that, dude, this won't compare because this is supposed to be in unsafe broke. So if you didn't know that you wrote unsafe code, you'd know from there, and you choose either to leave it or not to leave it. But at least with the knowledge that there is unsafe operations in my code. Uh, then why direct system calls? We use system calls instead of libc functions. Why? We need smaller binaries, so no like external library linking. We need more control over the behavior because we can't control what is in those binaries. It is harder to detect since it has no libc imports. It is hard to detect. Then better for shell code. So the impact is you have low level but more powerful. Another one, why stronger types? The decision, strict type checking at compile time. Why we have made that decision? To catch bugs early, prevent common vulnerabilities, makes code more maintainable, and it is self-documenting really. Uh, the impact is it is slightly more typing, but fewer bugs, just like Rust. Okay, to set up your environment, you can follow the installation guide in the documentation. I shared the link in the comment section, or else you can go to GitHub. You just type Cosma slash Project Ranga. I'm the only Cosma on GitHub, so you can easily find it. Then after the install, you can install the Debian version. Like I said, right now I want to have Debian. So if you want to test it, you can add Linux, either Ubuntu or Kali or another Debian system, or even WSL on your machine if you're not using it directly, and then you can install it and try it out. After installation, run the Ranga C that dash version to check the version you will be seeing. The Ranga compiler it's at the moment at version 3. Then choosing the editor, like I told you, we have some extensions, though they are not yet ready for stable release. But if you know how to tinker with extensions, you can again get them and set them up in your text editor. To create a workspace, you don't need a dedicated external dependencies to set up, or you don't need a dedicated IDE. Any can do, especially the terminals. So just make the directory where you're going to work from, and you cd into it. So your first code will look something like this. Here, your program ya Ranga ESOS. This is the first Ranga program. Don't worry if you don't understand it yet. Um, Just look it. If I can read it in English, every program needs a main function. So we start by defining the main function, and it returns a 64-bit inside integer. So we declare a variable like this. Let message, we add the colon. Ptr means pointer. The colon is a separator between the variable name and the data type, and then we assign it to hello, comma Ranga, then the new line mark, and we put a termination marks at the end. Then we let length, we add length variable as well. We assign it to a 64-bit inside integer. It can be a 8-bit, it can be a 16, it can be a 32, depends on your choice. So, and it's varies 15. Now make system calls to write to std out. To print or to print out anything in a Ranga, just like how you have printf in C, you have to write to declare any self operation, any self block, and within it do a syscall, and in a syscall you add a 1, comma 1, comma the variable containing the pointer message, and then the length of the value, the values that you want to print, the characters you want to print. Everything counts, even the space you have to count it. But the tab that n at the end is one thing, not two. Then your return is 0 to indicate success. What is happening here? If the first line fn main call is it the braces pointer returning 64-bit means that the main function returns the 64-bit number. Then the second line, let the message ptr creates a variable and points it to a string, and then the unsafe block makes syscalls as an marks the syscall operation as an safe, and then syscall we call the right syscall, and then the return is 0. It is an exit from the function, implying that it was successful. Don't worry about the complexity. The next lesson is going to be breaking it down. So what you'll learn in the next lesson, we are going to learn about how to write your first real world program, understand every line of the code, compile and run it, learn about the common mistakes. The lesson we've learned so far, what is Ranga and why it exists, the language philosophy, the design goals, how Ranga compares to other languages, why you can build with Ranga, and the key features and decision designs, and how to set up. Guys, this is the next big thing. If you are really enthusiastic about it, like where I am, um, whether you're going to find it later and you get time to watch it, please, you can leave a review about it. I promise I'll try to improve. I know the quality isn't so promising, the quality isn't so good, but we're trying. I'm trying, and trying isn't hard enough, but I'm trying, and I promise I'm going to give you better results, and I'm going to make it better every single day that we're going to be having a lesson, and I'll make sure that you, my friend, understand it the way I understand it, and maybe we can work on something together. So, guys, I think I'm going to end it here. This is a test flight for a live stream. I think I can try to do it. I'm not ready for it. Just when I came on and say, okay, today I have to learn about functions. But what about everyone else? Why don't I make a video to give people a brief overview because it has been a buzz on peer list. People have been asking for something like this in my inboxes on WhatsApp, on Telegram, emails, everywhere, and let's do it. Yeah. So with that in mind, I think I should move out at the moment. Thank you for your time. If you get an opportunity to watch the video, please you can leave a thumbs up or subscribe to the channel. But I don't emphasize that. I mean, and I'm not forcing that, but it will mean a world if you do so. You can react. You can drop a comment. I'll be reading through. I have a lot of time for communicating with people who love my projects. And again, you can click on the link and then visit the repo and check it out. See how it works for you. If it's nice, if it solves a problem or two with you for you, please recommend it to a friend. If you are a programmer, you good at compiler design, low level programming, C++, LLVM, please get in touch and let's see if you can collaborate on it. And like you can be added as a contributor on it because I work on it solely at the moment and it's a lot of work since it's not really a commercial project. It's free of charge. That's what I want to emphasize. No one is going to tell you don't use it. There are no rights. You can improve it however you want. No restrictions on it. You just have to give credits to the creators. So I think let me end it here. Welcome you from the boiling session. This has been for you. Um, thank you, Miss. What is the name? Miss Akoi. Thank you for joining. It has been really honor to have you around. I hope even next time you come around. I think I should end it here. I sign out. Peace.